Good morning, everyone. Welcome to the University of California, Davis and the 2024 Industrial Decarbonization Symposium. The Energy and Efficiency Institute could not be happier to convene this group of experts here today to work on this important topic. Thank you for joining us. I'm certain that with this group of distinguished presenters, the opportunities we have to ask questions, make comments, meet new people, network, we're all going to leave here with one and probably multiple action items on how to make production cleaner and more efficient. I'd like to just start by saying a little bit about who's here. We had well over 200 people sign up, people from the entire ecosystem of folks that are working and vital to making this transition. We have manufacturers here and trade organizations, a number of solution providers, people who work with these companies to make it happen. We have technology developers, the people that are coming forward. Our utilities are important partners. Government is here. A number of researchers from academia, from the labs. The financial community is here, and in academia, and included in the academic group, we have leaders of the Department of Energy's industrial assessment centers from across the nation right here. And each one of these centers does extensive work with the industrial communities, our facilities in their areas. So enormous expertise and opportunity for you to reach out to that group. We have, number of people from the distinguished leadership in California and the country. They're going to be up here. Commissioner Matt Baker is here. So lots of important people. Amongst the solution providers, one of the groups that are here is Cascade Energy, who is the founding member of our hub. And so we're very pleased to have them. My name is Kelly Kissick. I'm the faculty director of the Energy and Efficiency Institute, which is hosting this event. And as many of you know, our institute has a proud tradition of doing important research in buildings, in lightings, in water, and making big advances. And I will tell you that as faculty director of the Institute, I still learn every time I walk into one of our labs and talk to our researchers. I'm also a faculty member in mechanical engineering and our energy graduate group, and I'm constantly motivated and inspired by our students and their motivation to tackle the most important problems, I think, of our era. I'm also a faculty scientist at Lawrence Berkeley National Lab, and I get to work with some of the best minds and resources in the country, and we have significant participation from LBNL here. What's new in our institute is what's in red, and that is our our expertise on the industrial decarbonization side. I also had our Industrial Decarbonization Solutions Hub. We'll talk more about that going forward, but that's the primary sponsor. And Sabby Miller is here, and she heads our Materials Decarbonization and Sustainability Center, focused on materials, infrastructure materials primarily, which is a key component of the hub. And so I think you can see that each of us, everyone in the room here, has an incredible depth of understanding in our respective specialties. But none of us have the capability to move the needle individually. And that's why we're here together. is I think we need a better understanding of the constraints we work under, the opportunities that are out there, the solution sets, and a clear roadmap to make this transition effectively and efficiently. So I'd like to just say a couple things to frame the issue. And the first one is just to make clear the progress that all of you have contributed so vitally to in the energy picture. I'm going to talk about California here, but I want to use California not as, hold it up on a pedestal, but as an example of what happens in states in nations and stuff across the world. So if we go back to 2020 and we see how much energy we use, and we say, well, what if things stayed the same? What if the energy intensity of the economy stayed the same? And we look to 2020, well, over that period, our population grew by about 17%, and our economy grew by about 56%. So we'd be up at the top of that yellow line if things didn't change, okay? And what happened over that 20-year period is that we're now using 12% less energy than we did 20 years ago, okay, despite all this growth. That's remarkable. And so that difference is really the improved energy efficiency of the economy. Now, if you're familiar with this type of analysis, people always say, well, there could be structural change. This could be big energy-intensive industries moving to China and stuff. And so we've done some further analysis of the industrial sector, and we think it's minor, okay? We think this structural change is minor. People aren't moving out here. In fact, industries are moving into California. So this change is due to you folks, okay, in this room, and the efforts of lots of other people. If we step back and look at carbon dioxide or CO2 emissions, it's the same thing. If we go back to 2020 and we say, well, things didn't change, the energy intensity of the economy didn't change, the carbon intensity of energy didn't change, you can see that our CO2 emissions would probably be about 60% higher than they were in 2020. But what happened? They're about 20% lower. Okay, and when we break this down again, we see that the driver of decarbonization has been the energy efficiency in the economy, and to which all of you folks have contributed on to, and that's going to continue. So there's been a lot of momentum. We're doing a lot of great things, and I just want to point to the corporate world for a second, and share some of these things that you probably know. More and more companies are internalizing the need to decarbonize and signing up with very aggressive goals. Climate Pledge, which is a net CO2 by 2040 group, has 480 companies signing up, and these are many of the absolute leading companies in the United States and in the world. It's 10 million employees now are engaged in this transition. Internationally, one of the big groups is Science-Based Target Initiative, and they have 8,000 companies, okay, who have signed up to take action, and 3,000 are signing up for net zero commitments. So this is not this is not a narrow group, okay? It is giant, and in fact, I like to think of this decarbonization as the new normal. We can look at things broadly, the Fortune 500, the S&P 500, everybody, not everybody, but big parts of the corporate world are signing up, are internalizing this, and those numbers are just going to continue to grow as we go forward. So this is a quote I like at the bottom. It says, "Today the conversation is shifting from whether major companies will ever commit to net zero emissions to how they plan to achieve such ambitions. And I think that's our charge here, all right? I don't think you'd be in this room if you didn't understand the importance of it, right? But how are we going to move forward? And that's the question that the companies that come to us ask us. We know we have to do it. Here are our ambitions. How are we going to move forward? And I'm pretty sure that you're going to leave here with renewed motivation and a better understanding of how to do that. I'm just going to say a couple things about the structure of the agenda. I think you can all get it on your smartphone. There's QR codes you can scan and see. But the way today is set up is myself and my co-chairs are going to make some introductory comments here, and then we're going to open up with a plenary session. We have leaders from the California and the United States energy communities talking to us about what's happening, with policy, with regulation, with incentives, amongst these leading organizations. Then we have a break, and then we're going to have parallel tracks, and you're going to have to choose those tracks and which session to go to. My co-chairs are going to talk more about those, but I kind of laugh because when I go to conferences and there are these parallel tracks, I hate it, right? Because I'm greedy to learn. I want to be in all of them. And now that I'm running one of these things, I did parallel tracks. So, I apologize for that, but we had so many great people that we wanted to give you access to that you're going to have to make some choices. We're hopeful that all of you presenters will tell us, hey, it's okay to put your PowerPoint slides on the webpage. And so if you didn't get to see the presenter you wanted, I think you'll be able to see their materials afterwards. And certainly this is a small enough group that you can network, you can come up and talk to folks. Over lunch, I just want to point out also that we're going to have a poster session. We have a number of our students who are doing great research who, we couldn't fit into this, but they're going to be showing off a lot of their research. So please stop by and take a look at what's happening there. In the afternoon, again, 2 parallel sessions. We're going to all get together then near the end of the day for a closing plenary on the way forward, another group of really important leaders to help us think together about going forward. And then we'll have a happy hour and more chances to network. So thank you so much for joining us. I'd like to welcome to the stage Prakash Rao from Lawrence Berkeley National Lab and Sabi Miller from our Civil and Environmental Engineering Department here at UC Davis. And they're going to talk about these tracks, just set up the rationale and the speakers, please. So. Did you folks have slides? Did you have slides or no? Okay. Oh, I forgot. Thank you, Seb. Yeah. And of course, I want to thank our sponsors, the Ministry of Foreign Affairs of Denmark is contributing to this event. They've been great partners with us as they are leaders in industrial decarbonization. We're going to get to hear from them at the end. And I also want to thank our staff at the Energy and Efficiency Institute, all the people that work with Will and Sherry. You've received a lot of emails, and Karen and the entire group out there. So let's all give them a hand. It's a lot of work to bring this together. Let's see if I missed any other. Oh, there you go, Sabi.
Perfect. Okay, so I'm going to use the computer instead of the little microphone clicker. So just as a point of inspiration, this is actually where I grew up. My parents are farmers, so part of the reason that I'm really interested in sustainability is because we could actively see climate change affecting our agricultural processes in California. And we do have breakout sessions that are talking about agriculture, but those breakout sessions that I'm running are talking about materials production. And the reason that we're looking at materials production is because if you start to think about where our greenhouse gas emissions are coming from, we actually have a huge fraction tied to the production of materials. So right now, materials production is contributing almost a third of our greenhouse gas emissions. This is just fossil and process emissions. This is not including all of our forest fires, by the way. Those are doing their own greenhouse gas emissions. And part of the reason that we have these huge emissions is actually tied to a level of consumption. As humans, we need resources for our societal good, and those really large levels of consumption are actually what's driving the emissions. It's not to say any given material is bad, but rather when we use so much of a material, it starts to lead to high impacts. And just as a point of reference, global water consumption is still way larger than our materials consumption, but in terms of human-made materials, concrete actually is the second most consumed material on the planet. And again, this is driven in large part because there are more of us, we have growing wealth, and we like to have things like roads and sewer systems and hospitals. And in order to do that, we need to have a fair bit of materials consumption. This chart is just showing world per capita production of our materials. So keep in mind that I just showed you how rapidly our population's growing, and this is just per capita. So we have a huge degree of consumption that we need to deal with. And just as a point of inspiration, when we start to look at where those greenhouse gas emissions are coming from, we could start to think about this in terms of a mass of materials we need, and yeah, we need a heck of a lot of concrete. Or we could think about this in terms of a volume, and yeah, we still need a heck of a lot of concrete. But when we think about this in terms of where our emissions are coming from, we start to see the distribution shifts. So part of the producers that we're going to hear from today are not only discussing concrete, but also some of our other materials in order to start to see how can we reduce emissions tied to alloys, tied to plastics, etc. And since my background is in civil engineering, I must emphasize we are doing this while considering performance. The goal is not to compromise performance while mitigating greenhouse gas emissions. We also need to address things like dynamic effects. If we emit a certain amount of greenhouse gases today, those are now in our atmosphere. They are contributing to cumulative radiative forcing. What happens if we create a sink in the future, but we already sent a huge amount of emissions out today? It's something that we need to start to balance as we're actually analyzing our different fluxes. And of course, a huge amount of data and modeling are necessary for this, so you'll also hear about new modeling methods in some of our sessions. And while we always think global when we're talking about decarbonization, if we shift how we're producing things, it could start to shift local burdens as well, whether those be resource scarcities, air pollution, et cetera. So as we come up with new solutions, we want to come up with ones that have co-benefits that improve not only our global burdens of decarbonization, but also any local burdens that we tie to our materials production. So with that, we have 3 sessions that are focused in on materials. The first is session 3. So the first breakout, actually there are no materials related sessions. We don't start until the second breakout. So session 3, we have policy drivers, quantification for materials decarbonization. We have a lot of researchers presenting in this panel, including ones from UC Davis and Lawrence Berkeley Lab. We also have researchers from the UC Pavement Research Center, which spans a couple of UC campuses. And we also have some folks from the Air Resources Board and from the Rocky Mountain Institute speaking at this. The next panel that's focused on materials decarbonization is actually with folks that use materials and need those materials to hit net zero emissions in order for their companies to make net zero goals. So we have folks from Prologis, from Rivian, from the Department of Defense. The United States Department of Defense has net zero emissions goals, and from Google, who will be speaking on what they're looking for from materials producers, what their aspirations are, and what research and development they need. And then our last materials session is going to be focused in on actually making these materials. So we will have, as you could have guessed from that bar chart, a good amount of cement and concrete representation. So we have CEMEX and the California Nevada Cement Association who will be presenting. But we also have steel producers. We have Nucor that will be presenting, and 2 companies that are trying to change how we actually approach materials production in a way that should facilitate our producing those materials with net zero impacts to begin with, as opposed to trying to decarbonize. One is an alloys company, Magrathea Materials, and the other is a plastics company, Mango Materials. So with that, I will pass it back to Rao.
Hi all, I'm Prakash Rao. I'm a science, well, that's me. I'm a scientist at Lawrence Berkeley National Laboratory, and also I head our Building and Industrial Applications Department. I don't have slides, so I apologize for that, but I'm going to use Kelly's slides. Sleight of hand there. So I'm at Lawrence Berkeley National Laboratory, as I mentioned, and one of our founding principles, I guess, of the entire National Lab complex, and particularly at Lawrence Berkeley National Laboratory, is this idea of team science, right? And the idea is that we have these grand challenges, and no grand challenge can be solved by one individual scientific discipline. We need multiple scientific disciplines to come together to tackle things like, in the National Lab's case, it was the atomic age, right? And I can't think of a more grand challenge than decarbonization, and within that, I can't think of a grandest or hardest challenge than industrial decarbonization, right? So I think conversations like we're gonna have today, I think are just critical to bringing, it's not just the physicists and the chemists and the material scientists and the civil engineers and mechanical engineers, it's the social scientists and the behavioral scientists and the financial folks and the economics folks that all need to be coming together in all their various disciplines, such as the utilities, the government, academia, as Kelly pointed out, industry, technology vendors, coming together to solve this challenge. And one statistic that Department of Energy has published within one of their liftoff reports, 60% of the technologies that we need to decarbonize industry are not commercially viable today, right? So that means 60% of the emissions abatement. So you kind of start to process that in your head. Even if I had a magic wand, it wouldn't be that magical, right? It would only kind of get us so far. So that's why something like this today is absolutely critical. I think the conversations we're gonna have, the relationships you're gonna hopefully either seed or nurture or grow today is kind of the currency, I think, of our symposium. So one of the things that we've been talking about, and this will be the other track, is what are those solutions that can start to scale across sectors and really deliver impact? So we think of industry, you often think it's heterogeneous, and that's absolutely true. The way you make paper is not the way you make ice cream, right? It's totally different. But there are certain systems and concepts and kinetics that you can sort of start to see, all right, if I can apply this here, I can apply this there, I can apply this there, and we're thinking of this as a cross-sector technologies approach, and that's what you're gonna see in breakout session 1, 4, 6, and 8, the even number breakout sessions. Well, except for 1. And largely, we could sort of break these down into sort of 3 themes topically within the cross-sector. One is low temperature. So, I'll go with the other 2 themes. Electricity consumption in the context of the electric grid, and as well as carbon accounting. So on the low temperature side of these things, looking again at Department of Energy data, 52% of emissions within the industrial sector are from thermal processes. That's all emissions, energy or process. 52% of it is coming from needing to meet thermal demands. But of that, 36% of those emissions, or not those 52, 36% overall, is for temperatures less than 150 degrees C. So we think of industry as really hot. It is really hot. Steel's really hot to make. So is cement. But you don't go from 0 to 1100 C or 1200 C, right? Or in some processes, such as pasteurization, don't really go past 170, 180 C, whatever, or these lower temperatures. There's a lot of opportunity space within these low temperature. And if I extend that out to 300 degrees C, I've captured now 67% of those thermal emissions. So yes, industry's high temperature, but there's a heck of a lot of low temperature stuff in there that we could start to conquer, right? So when I put this all together, it kind of covers 2/3 of industrial emissions we could start to think about as being below, 2/3 of the thermal emissions being below 300 C. The next part of this is scope 2 emissions, right? So the electricity consumption that we have. Again, 1/3 of our industrial emissions are scope 2 from the electric side. The grid is changing, industry is a large user. How do we start to make the industrial facilities an asset rather than liability on the grid? How can they flex? And how can they enable sort of greening the grid? And how can they also sort of take advantage of times of low emissions intensity on the grid, right? So things like load flexibility we'll be discussing in our sessions. And finally, I think one of the really sort of silent topic that I think is on a lot of people's minds is the idea of carbon accounting. This is where rubber hits the road for me. It's how we track our progress, how we know how we're doing, how we know where we need to go. We need to have carbon accounting that's fair, right? That actually counts the carbon appropriately, that's communicable, that's related, that people can actually do and actionable. And so we have a great list of speakers in a session that's going to combine load flexibility and carbon accounting to round out. I believe that's our last session. Yeah, session 8. And Kelly already covered this, and I'm running out of time, but I know in the spirit of the hub and its team science approach, we have technology developers in our sessions from Grundfos, Stanfos, GIA, Armstrong. Industries represented with Chevron and Total. We have consultants from Cascade and DNV presenting. Rocky Mountain Institute is going to be on both tracks, so they'll be presenting here as well in carbon accounting. And of course, we have government presenting on this panel, such as CARB. So I invite you to obviously come to the sessions, but also engage in conversations, create those partnerships, and hopefully leave today with a lot of nuggets to act on and move forward in this challenge. So I'll hand it back to Kelly.
Thanks, Sabi. Thanks, Prakash.